Hey everybody, so today I want to just go through some stuff that we actually did at the beginning of the year on elements, compounds, and mixtures. So you'll remember that we did a lot of particle diagrams. So every time you have a particle diagram, I want you to have a key. Usually I have the key on the left and the particle diagram on the right, but make sure you make a key. So let's say we're making water. Water's formula is H2O. So that means I'm going to need two H's combined with an O. So let's say I make hydrogen be an open circle and oxygen be a filled in circle. Okay, so I have one O and two H's. And so that is a compound because it contains more than one type of atom bonded together, and it also has a fixed ratio. That means I always have two H's for every one O. And then I could continue drawing more in here. And right now it appears as though I have water vapor because I'm drawing them far apart. If I drew them closer together, I can make it a liquid or even a solid. All right, what does it mean to be a pure substance? So pure substance means that there is only one type of matter. So I'm going to show you two examples. This is a pure substance because they are all the same. And this that I drew on the last slide, this is also a pure substance. Now, what's the difference between them? This one is an element because there's only one type of atom. This one has two types of atoms, but both of these molecules are both water, which means it is a pure substance. So both elements and compounds are pure substances. They are not a mixture. Everything within them is the same. All right, how do you tell if a mixture is homogeneous or heterogeneous? So a homogeneous mixture is very well mixed. So I'm going to make a mixture of two kinds of elements. This is one kind of element, and the not filled in is another type of element. So I could have a key here, and I could say this is titanium, and this is nickel. And so in this container right now, I have a great mixture of the two, and it is very well mixed. So this is a homogeneous mixture. But over here, I could show something different. I could have water. I'll make a key in just a second. And then I could have some iron. So my H2O looks like this. And my iron looks like this. So this would be my key. And this is heterogeneous because it settles. The particles do not mix well, and so I end up getting layers. This one was very well mixed, and so that's why it is homogeneous. Another word for homogeneous is a solution. So a solution is a homogeneous mixture. And if it's aqueous, that tells us it is mixed well with water. So let's think about what mixes well with water. Salt does. So NaCl, if I put a little AQ after it, that is an aqueous solution. AQ for aqueous, solution because it's a homogeneous mixture. So if I wanted to show it in a particle diagram, I could make my little key. I could have NaCl, H's, and O's. So I already used this and this for my H's and O's. So let's use these for my Na and Cl. So I could have some water. And I could have some NaCl. Now when NaCl is in water, it actually separates. So I could have Na here, Cl here, and Na here, and a Cl here, another Na here, and a Cl there. So it's very well mixed. That is what it looks like when it is aqueous. All right, what can be separated into simpler components? So know an element. An element is already in its simplest form. So when I have an element, I either have a monoatomic element or a diatomic element. And either way, it is just an element, so I can't separate it. A compound, so this is can I separate? I can separate a compound, but not easily. A compound can only be chemically separated. And so what I mean by chemically separated, it has to undergo a chemical reaction, a chemical change. So for example, water. Water does not naturally change. Oh, we should be seeing this in the lab actually. When you heat up water, you are just changing it from a liquid to H2O gas. So this is only a physical change. You did not break it down into anything simpler. It was a compound at the beginning and it's a compound at the end. But if you did a chemical change, you could actually separate the H2s, and oxygen's actually diatomic too, so it isn't balanced right now. But this is actually a chemical reaction. So to get the hydrogen gas and the oxygen gas, that is not easy. That would require a very difficult chemical change. All right, and then mixtures. Any mixture can be physically separated. Again, not always super easy. Sometimes it is, but there has to be a process to physically separate a mixture, because a mixture, they have not recombined to form a new chemical formula, so they still retain their same properties. So I should be able to separate a mixture. There's several ways. So the first way, and we did these in lab this week. So the first way is filtration, and this is when you have a solid in a liquid. So if I have sand and water, I could set up a filtration. So you set up a little flask, have a little funnel, pour it in, the liquid will come out here, and the solid will remain in here. So that's how you separate a solid that's in a liquid. You could do evaporation, and that is to remove a solute in a liquid. So a solute is something that is dissolved in the liquid. So a great example of this is salt water. So if I put salt water through a funnel like this, it wouldn't do anything because the salt is dissolved in the water. But instead, what I could do is I could put the salt water in a dish and I could heat it up. So here's my Bunsen burner. I heat it up and the water is going to evaporate out and the salt will remain on the bottom. So that's how I could separate that. Another type of separating solutions. So let's talk about this for a minute. When I am doing filtration, I am separating a heterogeneous mixture because you see the clumps of whatever the solid is in the liquid. If I'm evaporating, I am separating a homogeneous mixture, a solution. And this third one is called distillation. And distillation is also for a homogeneous mixture. And this is for when you want to separate two liquids, and it's going to be based on two different boiling points. So let's say I have a mixture, and in this liquid, there are actually two liquids. One is water, and one is alcohol. This alcohol, let's say it has a boiling point of 70 degrees, and we know water has a boiling point of 100 degrees. So what I could do is I could heat this up, and when it reaches the first boiling point, so when it reaches 70 degrees, what's going to happen? This alcohol is going to change from a liquid to alcohol as a gas. And if I just do it in the air, it's going to escape out into the air. If I put it into, okay, let's say I have my little container, but I close off my container. Actually, it would look better if I made it a test tube. Let me try it like that. Let's make it look a little prettier. Okay, let's say this is my test tube and I have a stopper in it, and there's a little piece of tubing. And the tubing can lead me to another container. All right, so I put my flame under here and I start heating it. And inside of here, I have alcohol and I have water. So when I start heating it, the alcohol is going to boil off first. And as it boils off, it's going to collect over here because it's going to condense. So over here, I will have the alcohol. And when the temperature all of a sudden changes from 70, and it's going to stay at 70 until it has boiled off all the alcohol. So it's going to stay there for a while. And then eventually it's going to go up again and then be like, okay, now I'm at 100. Well, before that point, I want to stop my fire because once you go above 70, I only have water left in here. So I disconnect it and now I've separated them. The alcohol is over here and the water is in here. So that process is called distillation, separating two liquids based on the fact that they have different boiling points. Whichever boiling point is lower, this one is going to boil away first. And if you want to collect it, you have to have some sort of a tube to collect the gas. Otherwise, the gas will just escape all over the room. And then the fourth one would be chromatography. And this is something that we definitely do in biology. It's a great way to separate pigments. And so you could take a leaf. Here's a leaf that you might find in your yard. And you can literally break up the leaf and get the liquid from it. And you take a piece of chromatography paper and you take the liquid from breaking up this leaf and you make a nice line here on your chromatography paper. And then you set your chromatography paper in a solution. And you make sure the solution is lower than the line. And this solution is usually some type of alcohol. And alcohol will attract to this paper and it will start moving up this piece of chromatography paper. And as the alcohol moves, it will absorb and dissolve some of the pigment. And what it ends up doing is giving you different layers to your, different layers of your pigments. The further it can move, okay, so let's say we have one travel to here and one travel to here. So this is one pigment and this is a second pigment. And it's moving based on its size and based on its attraction to this paper. So the first pigment is definitely heavier and this one would be a lighter one because it was able to move further. And so it's attracted to the paper, it was attracted to the alcohol, and it moves up according to that size. All right, so that is our refresher today. Oh, let me make one more slide, actually. We also did physical versus chemical change. Earlier this year. And so when you have a physical change, you still have the same substance. It might be in a different form, but it's still the same substance, which means it still has the same properties. But when you do a chemical change, the substance changes. And when it changes, it takes on new properties. So I love to give the example of salt, NaCl. Na, sodium, is actually a metal. Cl, chlorine, is actually a poisonous gas. But when the two come together and form salt, we eat it. So who would have ever thought that we would be eating a metal and a poisonous gas? But they have new properties when you put them together. So they're no longer this individual metal or individual poisonous gas. It's now salt, which we eat. So if you have any questions, just let me know. I'd be happy to go over more of this. Your task for the rest of the day is to work on a practice. And once you do the practice, you can check with the key and make sure that you are doing the practice yourself first. You can definitely ask each other for help and work on it together, but you are the only one that knows if you really understand it. So make sure that you are also working, really thinking about each problem as you do it. When you are done, check with the key, make sure you got it right, and then I want you to do both the pre-quiz and the quiz. Now, the pre-quiz and the quiz, I want you to do all by yourself. I want you to show yourself, yep, I definitely understand these things that I was working on, and I am able to show that by how I score in this quiz. All right, have a great day, everybody. Bye.